Welcome to the Crazy Hat Chemist, another video in bonding and molecular structure. So let's get moving. Bam! So today we're talking about xenon tetrafluoride's molecular geometry and oh, so much more. So xenon tetrafluoride. Tetra is for four. So how many fluorines do you have? 4. So one xenon. Okay, so xenon tetrafluoride. Going to look at our periodic table and determine the number of valence electrons for xenon. That's 8. Fluorine, that's 7. There are 4 of those fluorines, of course. And then we're going to add these numbers up and we're going to get 36. We're going to divide it by 2 and we're going to get 18 pairs of electrons. That is, the least electronegative goes in the middle. That's the xenon. Those fluorines surround it like the X marks the spot pattern. We're going to place pairs of electrons between the central element and the outside element, and that is right there like that. I still have electrons left over, so I'm going to place lone pairs of electrons around these outside elements, and that goes there like that. Okay, you should see that fluorine has an octet. But there are 2 pairs of electrons left over. What do I do with them? Dump them in the middle. Now xenon is hypervalent. It is period 3 or greater. It can exceed the octet rule and be hypervalent. I'm going to verify the octet rule for each of the fluorines. I'm going to tidy up this Lewis dot structure, make it look really nice, because I got single bonds as lines instead of little dots. All right, there that is. Okay, so I got that xenon in the middle. I got 4 bonding pairs, okay, and I got 2 lone pairs. I'm going to get my axe-like structure. The A is the xenon, that's the central element. The X or the F are the 4 fluorines, so it's AX4, and then I got 2 pairs of bonding. 2 pairs of non-bonding regions there on the central element. So that's AX4E2. There it is, AX4E2. How many bonding domains? That is 4 bonding domains. How many non-bonding domains? 2 non-bonding domains, and that's that, 4 and 2. So either from the 4 and 2 as far as bonding and non-bonding, or the AX4E2, then you should get the name of the shape. You have to memorize the name of the shape corresponding to the axe or just the bonding and non-bonding domains. Okay, so that name of that shape is square planar. What are the bond angles for square planar? Those are 90 degrees. We're going to get the hybridization of this, and we're going to count the regions around the central element, whether they are bonding or non-bonding. So S, P1, P2, P3, D, D2. That's SP3, D2 hybridized. Bam! I like that. Now we're going to get the polarity of this structure here. So I'm going to show you this first. I'm holding on to the lone pairs of electrons on the central region. It is most certainly square, planar in structure there. Okay, are there polar bonds in here? Yeah, the xenon, the fluoride, that has a difference in electronegativity. So the first criteria for polarity has been satisfied, i.e. it has polar bonds. However, is this molecule symmetrical or asymmetrical? That is the second question that must be satisfied in order for this to be polar. And this is symmetrical because all the fluorines, the green things, are the same, and these lone pairs of electrons are opposite each other, making it symmetrical. So that means that this molecule here is non-polar. Yes, that is right. Lone pairs on the central region, and it makes it non-polar. Very unusual, just like a linear structure with the 5-domain structure that we had talked about before. Okay, I love that, and I love this hat. I love Italy. Oh yeah, baby. Love Italy. Give me a thumbs up if you love Italy. Give me a thumbs up if you like that video. Subscribe to my YouTube channel, and I'm going to see you next time because we're going to be talking about compression. Have a good day. See you next time. Bye now.